Hi, everyone. Hello. I know it's never easy to do a presentation after lunch, but well, let's see. Okay, so I'm here to present on DNSSEC deployment status in Africa, and let's start with the beginning. What is DNS before even heading to DNSSEC? So on the internet, we are users, and there are resources that we want to try to connect to. Either we are trying to reach a website, or we are trying maybe to get into the Zoom to access this session, or we want to watch a movie, etc., etc. All those resources are stored in different locations on different servers, and we need the IP address because this is the unique identifier that helps to identify the location of the different resources on the internet. But we as human users of those this infrastructure, we are not very good at keeping numbers because those IP addresses are numbers. Well, we are good at other things, but not at numbers. So there was the need to find this translation interface for us to continue using the names that we are good at, and letting that system translate those names into the IP addresses, right? So we can, from that, understand how critical is this system, which is called domain name system. You can have gigabytes and gigabytes of connectivity with your ISP, but if the domain name system is not working, well, you are not going to go anywhere unless you have the IP address and you can type them into the browser. But I don't know how many IP addresses you can keep in your mind. So how critical it is has also been proven by some of those incidents we have had on the internet these recent years. You have probably heard about, well, I'm not going to name any of those providers, but yeah, we faced some issues on those on the internet these recent years. But on the other side, there is also a reality that, as any other system, the DNS is also vulnerable. It has some vulnerabilities. There are some limitations in the way it runs, right? There was no security by design at the time the DNS was built, and the decentralization, the fact that the DNS is also a very well distributed infrastructure with so many actors that play different roles, just adds a level of vulnerability to the overall system. So you have probably heard about some attacks that happened on the internet. You can Google some of them, like DNS espionage or CISO troll or avalanche malware. 2 days back, John, in his presentation, mentioned about the abuse of the DNS, and yes, those are realities that those bad actors are using on their best to actually conduct the attack. And the reality is also that, well, we have some solutions that exist to protect our network perimeter, but those systems do not really help protect all the vulnerabilities of the DNS. We need to also understand that. So how do we do to first understand all those vulnerabilities and how we should, or what additional measures we should put in place to actually reduce the likelihood of going through such kind of incidents? This is probably where, or one of the places where DNSSEC actually falls in. So with DNSSEC, which relies on cryptography, public key cryptography, we will be able to authenticate, at least the systems, the devices will be able to authenticate the DNS response that is coming from the DNS authoritative name servers that provide the different answers for the domains we are trying to resolve, right? So with DNSSEC, we are adding security, we are adding reputation to the overall internet, because we can now trust the answer that we are getting. We can now have confidence that the IP address of the resource we are trying to reach is the good one, and we can get to it. Let's imagine that I want to try getting to my website, to my bank website, maybe to do a transaction, right? Or I want to do an online payment. But what is the evidence that I have? What is the level of confidence that I have that I am on the right website? I used to hear people saying that I trust the padlock, the green padlock. It is not enough for one reason. The DNS takes place before you get to that padlock. So if someone is able to hijack that DNS, he will just redirect you to a fake destination where he has set up the padlock as well. So everything will be green, but yet you are on the wrong website. So we need to understand that DNS actually takes place before you get to the resource itself. And we need to understand that DNSSEC can help us authenticate the DNS answer, the response that we receive, to be able that, yes, I can trust that destination I am able to reach. So now, what is that DNSSEC in practice? DNSSEC actually requires two actions for its implementation, for its effective implementation. The first one is to generate some key pairs and to sign the resource records. Where do we sign the resource records? On the zone. So the domain administrator, the zone administrator needs actually to perform some administrative tasks to be able to generate those signatures. Once they are generated, he will also publish them in the same zone file as he used to do for the normal resource records. There are some additional steps. I won't go into the details here. There is something that we call the chain of trust, and it is extremely important for the whole DNSSEC to actually work. So the principle is that if someone is able to hijack your domain name, because of this chain of trust, he has to also go to your parent to also hijack your parent to modify or to update the keys there. So it makes it more difficult for the hackers to actually hijack the overall infrastructure. And on the other side, of course, we have what we call the validation, the DNSSEC validation. So one thing is to sign the records, to generate those signatures, but the other thing is to verify those signatures. Let's take the banking system again. So you have got some checks, you go to the bank and just imagine that the bank agent doesn't verify the signature and just proceed. He will be in trouble probably. So adding this level of verification is extremely important. But of course, the validation is not done by the domain owners, but it is done by the internet service providers, those who help us connect to the internet. They are the ones who also provide us the DNS systems that help us to resolve all our DNS queries, right? So we have some recursive resolvers that are public, like the Quad 8, the Quad 1, etc., etc. But most of the time, our different internet service providers also configure and make available those DNS recursive resolvers for the internal usage, right? And this is the place where we activate that validation to actually verify the signatures against the public key, which is, by the way, also published by the domain administrator, just to make the link between the signature and the public key to make sure that this public key, which is announced in the zone, corresponds to the key, the private key that has been used to generate the signature. So there are some technical work that are done there, but this is not the purpose of the presentation here. And of course, one without the other is almost as if you are not doing anything. So the domain administrators need to sign, right? And sometimes we have DNS hosting providers because not all the registrants have the capability to run on their own the DNS system. So the DNS hosting providers, the registrars are also really important in the signing process. But at the other time, we also need those ISPs all over the world to be validating more and more traffic. So let's now get into the statistics to have a better understanding of how DNSSEC is deployed in Africa, in our region. So let me start with the two letters, CCTLDs. There are 54 in the continent. Those two letters represent the digital identity of each of our countries. They are always two-letter digits, right? Like .ZA in South Africa. Out of those 54, I'm not sure that you can easily see, I think 20 or 21 of them are effectively signed as of today. 3 of them are, let's say, partially signed, and the rest are not. There is still a long way to go. We also have what we call internationalized domain names, country code top-level domain in the continent. There are 6. Out of the 6, 3 of them are effectively signed with DNSSEC. But we also have 4 generic top-level domains. And by the way, all of them are in South Africa, right? So we have the .Africa, we have .Joburg, .Durban, .Cape Town. I think those are the 4. And all those 4 are effectively DNSSEC signed, active. That's really good. So another takeaway from these statistics is that 3 two-letters CCTLDs are partially signed. What does it mean? It means that they are doing some tests, probably. They have generated the keepers. They have signed the domain, but they have not yet established that chain of trust with the parents. This is how we secure actually the whole infrastructure. But for several reasons, they have not yet done it. One two-letter CCTLD is signed on only one of the name servers. They are probably also in test. This was seen a few months ago, and let's see. In the next couple of months, they will probably roll out on this. We can clearly see that this RSA SHA 256, which is algorithm 8, is mostly the preferred one. So to make it simple, there are different algorithms that we can use while generating the keepers to sign the zone. Some of them are now deprecated, others are more recommended than others, etc., etc. For that one, we just follow the cryptography, ecosystem, and we try to adapt them the most to the DNS infrastructure. 2 or 3 of the CCTLDs have rolled the algorithm. They were using previously different kind of algorithms, and now they are using ECDSA 256, which is algorithm 13. Well, and much more to say. We can go into a lot of details, like the deployment at the 2nd or the 3rd level. But for that one, we need statistics from the CCTLDs. Some of them are actually publishing the data, others are not. And probably we can also touch a bit about those who are not yet signed. Sometimes there are different reasons, but we are not going into those details here. Now let's get into the algorithms that are used. Those are some graphs for those who like statistics and graph. Yes, we can clearly see that, as I mentioned before, RSA-SHA 256 is the most preferred one. But since 2-3 years now, we are seeing ECDSA also appearing. ECDSA is used by CCTLDs that are signed like 5-10 years back. So they have rolled the algorithm to ECDSA, and let's see how also it moves on in the next couple of years. Now back to the RSA-SHA 256. Here we can choose different length of key size, and we can see that the 2048 key size is the most preferred one for the zone signing key, which is the key that helps to sign, to generate the signatures themselves. But on the other side, on the KSK, which is the second key pair that helps to secure the first one, 4096 is preferred as key size for up to 10 CCTLDs. Well, there is a finding here which probably needs much more investigation, but so far what we have noticed is that due to the size of this key, sometimes the resolution takes time, or getting even the DNS key which is quite important to do the validation. The resolvers actually need those DNS keys to perform the DNSSEC validation, but sometimes we get data truncation and retrying in TCP mode, which actually add more delay in the DNS resolution. But we need some additional investigation to better understand the impact on such kind of things. Well, we have also seen that some operators are not rolling the keys. There could be different reasons to that, but something which probably will be good to see is if the DNSSEC practice statements actually match with what we are seeing on the systems. Because one of the recommendations, one of the best practices when you sign with CCTLD, with DNSSEC, sorry, is also to publish a document which is called the DNSSEC practice statement, which actually helps everybody, the public, to understand how you are doing your DNSSEC and how trustworthy is your DNSSEC infrastructure. The same on the KSK as well. We are seeing some keys that have never been rolled after even 12 years and more. It will be probably good to hear from them the reasons, and we can learn a lot from that as well. So let's now get to the second part of DNSSEC, which is DNSSEC validation, right? Which occurs at the ISP's level. So thanks to Epinic lab, they provide those statistics, and we can clearly see that Africa is around 32% of DNSSEC validation. The world is 31%, and of course, Oceania and Europe are quite doing much better than the rest. But if we get in details in the region, we can see that Southern Africa is validating much more than, let's say, West Africa, for example, right? Even when you get into that statistics, you can clearly see that some of those countries are still red, others are yellow, others are. We are getting much more green now, but still we need to continue the efforts. And here I need to also clarify that, you know, the number of internet users differ from country to countries, right? So there are some big giants there in the region who needs to validate. If we want to see big change in these statistics, we need the big ones, right, to now start validating. We are doing, our team, the office of the CTO, the technical engagement team, the GSE team are doing a lot of efforts to reach out to the ISPs individually, the operators individually, to train them, to make them understand why we need to do this to implement DNSSEC, why we need to activate DNSSEC validation, what is their role, and how they can do it. If they want support, if they need support, we are also available. We do provide them support. We have done this with a couple of operators in the region, and it has been a clear success. Since 3 years, 2 years, and even last year, we have supported some ISPs there. So feel free to reach out to us, either myself or GSE team, Yaovi, June. Well, Bob is no longer part of the GSE team, but I know that he is still supporting a lot, and please reach out to us if you need support. You can also go to John, by the way. So in terms of opportunities, there are a lot of opportunities there, definitely. Let me start by what ICANN does, right? So we do a lot of technical support. By technical support, it means training, to train people on systems. Last week, during the AFNOG sessions, we had 2-hour sessions to help people understand how, let's say, I won't say easy, but if you follow the practices, it becomes, you know, much less painful. To deploy, to sign the system, but also to validate. We provide virtual machines. You can play with them and get, you know, enough confidence to now get the deployment in your different infrastructures. And we also do support CCTLDs who are willing to drive them through some testing phases, right? So they run, they operate, they provide the resources, and we guide them on how to proceed. We have published a document which is called the DNSSEC Deployment Guidebook for CCTLDs, but it's not only for CCTLDs. Any operator who wish to actually sign DNSSEC, sign their zone. We know that some ISPs, by the way, host zones for their customers, right? So you can also refer to this document to understand what it is, how to sign. But it is not really a technical document. So even managers can actually go through this document and understand which kind of support I can provide to my technical team to make this thing work, to make this thing operational in our infrastructure. And we have Kindness, which is a new program that we are supporting at ICANN also, which promote best operational practices. And of course, DNSSEC is part of those best practices. There is now the Coalition for Digital Africa, and one of the initiatives out of this coalition is to support operators to deploy DNSSEC in the country. And of course, we are not alone. There are several other organizations in the ecosystem that also provide DNSSEC training and different kind of support. I think 2 days back, we saw Mark who was also providing some additional details on that. Now, in terms of perspective and future work, This presentation actually helped me to identify some new areas of investigation. And I'm seeing a lot of work for my next couple of months. At least I think that I will deserve my salary for some time again. But yes, there is a lot to do. We need to conduct a lot of measurement, a lot of research. And this is probably somewhere the local organizations are also really needed here, because as I used to say, I cannot be everywhere at the same time. I cannot be doing many things, right? But there is a lot to do. We need to conduct a measurement to understand the real impact of the findings we have noticed. We need to reach out to the operators, talk with them to understand why they are doing things the way we are seeing it, and which kind of support they probably need, they may need, etc., etc. So there are so many questions to actually answer. And yes, I will probably would like to also hear from you while we are present here in terms of suggestion, in terms of contribution, how we can do the things in different way to actually increase the uptake of DNSSEC in our region. Yes, in conclusion, there are some DNSSEC success stories in the region. To be honest, some CCTLDs have signed. The first one was signed since 2009, and it is still operational. Even it was signed before the root zone, you see. So there are some success stories, definitely. Some CCTLDs have rollover the algorithm, which means a lot from technical perspective. They have rolled even more than twice. Some have rolled 3 times already, and it is working, right? Some registrars also are supporting a lot by making DNSSEC available in the infrastructure. But still, of course, there is a long way to go. If you compare our statistics to our other regions, yes, you can see that other regions are, some are far away, others are in front of us, and we are, let's say, the last region in terms of DNSSEC deployment at CCTLD level. And of course, it is still necessary to continue working together. There is no single organization that can handle all of this. It is a together effort, and I hope that we will continue in that direction. With that said, I'm at the end of the presentation, and I'm open to any question if there is. Thank you.
Good afternoon. My name is Idrissa Sarr from Senegal. Thank you, Yazid, for your presentation. I would like to hear more about the success story within the country of Africa. Because when you back to your slide where you present the top 10 countries who already signed with DNSSEC, we can see that the Equatorial Guinea leads the group. And if you can confirm that we did a couple of capacity development sessions the previous 2 years in Senegal. And what we can see is that the number is still very low. So can you tell us more about how this country gets this number? What are maybe the best practices they use to get there? Thank you.
Okay, thank you, Professor Idrissa. So for the 10 countries, you are probably referring to the validating countries. So those ones, yes, there are some explanations. And this is also why I said if we are willing to see a deep change in the statistics, we need the giants to move, right? So if you go into the details, you will see that the top 10, out of the top 10, I think only Morocco, which is 85% now validating, is one of the big countries. When I say big countries, it is in terms of number of internet users in the country. So Morocco was just, I think, 5% validating last year. We did a work with them. They have 12 recursive resolvers. We work with them until all the 12 recursive resolvers are doing DNSSEC validation now. And the change was just wow. So again, back to the Morocco case, we have a good relationship with the regulator there. I just dropped them an email. They distributed that email to all the operators, and some of them come to us, right? And we started providing support to them. And this is the results that we are having now. So the approach is quite simple, but yet we are not able to understand why it works much more easier in some countries than others. To be honest with you, if we are able to change the figures in 4 countries in the region, you will be surprised the ratio of DNSSEC validation that Africa will have. So how do we together again, because we have to do it together, how do we together make this successful? That is the question. So the rest of the 9 others are not big countries, and the way they are also validating without going into the details, it is slightly different. So some of them use forwarders and they are forwarding to public recursive resolvers, etc., etc. So the figures are quite different from a country to another one. And this is our role to support, to understand what is the current configuration, what is the current design, and how we can make this successful, how we can make it active. That's it. Thank you.